We now determine the radius and height of the cylinder such that it maximizes the volume of the cylinder. Here we are given the diagonal equals root 48 meter, and this is fixed. And the equation for diagonal is given as square root of 4 times radius square plus height square. And we also know the volume of the cylinder equals pi times radius square times height. So first we are going to use this diagonal equation. And before that, let's denote the radius by r and the height of the cylinder by h and the diagonal of the cylinder by d. So let me consider this diagonal equation. I write down this in simple form as d equals this is square root of 4 times radius square. So it is 4r squared plus height square, which is h squared. Now we are already given that diagonal equals root 48 meter. So I replace diagonal by root 48, and this equals 4 times r square plus h square, and this is under the root. Now let's square both sides so that we get rid of this radical, and square of root 48 equals 48. And when we square this right side, this square root and this power of 2 will get cancelled. So we'll be left with 4r squared plus h squared. Basically, we want to solve for h using this equation so that we can replace this height in volume equation. So first, let me solve for h squared by subtracting 4r squared from both sides. So therefore, we get h squared equals 48 minus 4r squared. We then take square root on both sides so that we solve for h. So we get h equals 48 minus 4r square, and this is under the root. Now we consider the volume of the cylinder formula and determine the volume. So let's write down the volume equation. We have volume equals pi times of radius square. So replace radius by r times h is the height of the cylinder. This is the equation for volume. We now replace h by this expression that we obtained. So this becomes pi r squared times h is replaced as 48 minus 4r squared under the root. Now to find the maximum volume, we have to find the critical point of this volume function. That is, we have to set up the equation dv by dr. This equals 0. And from this, we determine the corresponding radius, which is basically the critical point of the volume function, or at that value of r, the volume will be maximum. So let's find the derivative of this volume function. We do dv by dr, and this equals here we can apply the product rule of differentiation. Consider this pi r square as first, and then this expression as the second. So I write the first expression now, first term. Multiply this with the derivative of 48 minus 4r squared. So this is basically 48 minus 4r squared. When we write this in power of 2, we write down like this. And so when we find its derivative, let's find the derivative of this one. This will be 1 by 2 times 48 minus 4r squared, and then 1 by 2 minus 1, which is negative 1 by 2, and then apply the chain rule to find the derivative of the inside part, which is the derivative of 48 is 0, and then the derivative of negative 4r square is negative 4 times derivative of r square is 2r. And so this one is negative 4 times 2r is negative 8r. We can replace this as negative 8r. And in fact, we can also cancel this 8 with the 2 as this goes 4 times. So we can remove this half in front, and then this one is negative 4r. So I write negative 4r times 48 minus 4r squared raised to the power of negative half. We will write down this derivative over here. This equals negative 4r. We can write down this power of negative 1 by 2 as divided by under the root of 48 minus 4r square. So this is the derivative of the second term. Now we put the second term, that is 48 minus 4r squared under the root, and then multiply with the derivative of pi r squared, that is pi times of derivative of r square is 2r. Okay, so we will now simplify this and replace dv by dr equals 0. So I'm going to replace this by 0, and this equals pi r squared times negative 4r. This equals negative 4 pi r cube divided by square root of 48 minus 4r square. And this one is 2 pi r. So I write 2 pi r times the square root of 48 minus 4r squared. So we have to determine r from this equation. So let's add this expression to both sides. And when we do that, we get 4 pi r cube. This is divided by 48 minus 4r square. This is under the root. And this equals 2 pi r times the square root of 48 minus 4r squared. Now we multiply both sides by the denominator of the left side expression. So when we do that, we get 4 pi r squared, and this equals 2 pi r. We have this same quantity over here. So this quantity multiplied with this quantity, we will see that the square root will get removed, and we will be left only with the inside expression, that is 48 minus 4r squared. Let's simplify the right side expression. So here we have this one is 4 pi r cube, and this equals, let's distribute this. 2 pi r times 48 is 2 times 48 is 96 pi r minus 2 pi r times 4r squared, and this equals 2 times 4 is 8. We have pi, and then r times r square is r cube. Now we add this expression to both sides, and doing so we get we already have 4 pi r cube, so it will be 12 pi r cube. This equals 96 pi r, and then subtracting 96 pi r from both sides, we get 12 pi r cube minus 96 pi r. This equals 0. We factor pi r from both terms, so I'm factoring pi r. Then I'll be left with 12. This one is r square minus 96. And so this equals 0. Dividing by pi r, or we can set this up equal to 0. Pi r equals 0. This gives r equal to 0. But this is not possible, so we can ignore this value of radius. And then we set this up equal to 0, that is 12r squared minus 96 equals 0. We add 96 to both sides, so we get 12r squared equals 96, and dividing by 12 we get r squared equals 8, and this implies we take square root on both sides, that is r equals square root of 8, or this equals 2 times root 2 when we simplify. So we have found out that r equals 2 root 2, and this is in meters, and this value of radius gives the maximum volume, which means we can now determine the corresponding height of the cylinder using the relation between height and radius. So we can use this relation, that is height equals square root of 48 minus 4r square. So let's use it here. 48 minus 4 square. And this is under the root. We can replace r by 2 root 2, or otherwise we can replace r squared by 8. So this becomes 48 minus 4 times of, if r equal to 2 root 2, then r squared equals 8. So I'm replacing r squared by 8, and so this equals 48 minus 32 equals 16. Square root of 16 is 4. So we found that height of the cylinder is 4 meter. So therefore we say that radius of the cylinder equals 2 root 2 meter, or otherwise this is approximately 2.83 when we round this to two decimal places. This is in meters, and the height of the cylinder equals 4 meter. So thus we have determined the radius and the height of the cylinder, which maximize the volume.